All right, today we are going to demystify two of the biggest ideas in all of math, domain and range. And believe it or not, we're going to start this whole conversation with cookies.
So let's kick things off with a question that might sound a little weird. What on earth does a recipe for chocolate chip cookies have in common with a math equation? I mean, they seem like they're from totally different universes, right?
Well, the surprising answer is they're both functions. Think about it. A recipe takes inputs, right? Flour, sugar, eggs. You follow a set of instructions, and you get one very specific output: delicious cookies. A math function? It does the exact same thing.
Okay, so let's imagine a great metaphor for this whole thing, the function machine. You put something in the top, and input, we'll call it x, and the machine does its thing, follows its rules, and then bam, it spits out one and only one specific output, which we call y. It's simple, it's predictable, and it's actually incredibly powerful.
But this leads to a really important question. Can this machine handle anything you throw into it? I mean, what if you decided to put sand in your cookie recipe, or tried to use an ingredient that just, doesn't belong? The whole thing would break, right? And that, right there, is where our first big idea comes into play.
So, we need to talk about the rules for our inputs. And in the world of math, this has a name: the domain. Think of the domain as the official user manual for our function machine. It's the part that tells you exactly what you're allowed to put in. It's the complete list of all the possible input values, all the x values that the function can handle without, breaking down or spitting out a math error.
Now, some of these machines are super tough. Take something simple, like a polynomial. Say y equals x plus 5, or y equals x squared. You can plug in pretty much any real number you can think of for x. Positive, negative, zero, fractions, whatever. And it's always going to give you a valid answer. For functions like these, the domain is easy. It's all real numbers.
But a lot of other function machines are a bit more delicate. They have these critical safety warnings almost printed right on the side. And we're going to focus on the two most common rules you're going to see that limit what you can put in.
All right, rule number 1. This is probably the most famous rule in all of math. You can't divide by 0. It's the big one. I mean, think about it. 8 divided by 2, no problem, that's 4. But if you try to divide 1 by 0, the whole system just breaks. The machine gives you a math error. It's just undefined.
Okay, so how does this actually work with a function? Let's look at this one. F of x equals 1 over x minus 2. See what happens if we try to plug in the number 2 for x. The bottom part of that fraction, the denominator, becomes 2 minus 2, which is 0. Uh-oh, the machine just broke. So the user manual, the domain, for this function is going to say, you can use any real number you want, except for 2.
All right, on to our second big safety rule. When we're dealing with real numbers, you absolutely cannot take the square root of a negative number. For sure, the square root of 9 is 3. That's totally fine. But what about the square root of negative 9? Well, that doesn't give us a real number. It's just another way to break our function machine. So let's say we have a function with a square root, like f of x equals the square root of x minus 1. How do we find its domain? It's actually a pretty simple 3-step deal. Step 1, just look at what's inside the square root sign. In this case, it's x minus 1. Step 2, apply our new rule. Whatever is inside that root has to be non-negative, right? So it has to be greater than or equal to 0. That gives us a little inequality. X minus 1 is greater than or equal to 0. And finally, step 3, just solve it, which tells us that x has to be greater than or equal to 1. And boom, that's our domain.
Okay, we've pretty much got the input rules down. So now let's flip our function machine around and see what kinds of things can come out the other side. This brings us to the range.
So what is the range? It's simply the complete set of all possible output values, all the y values that our machine could ever possibly create. If the domain was our list of approved ingredients, then the range is the list of every single type of cookie we could possibly bake using those ingredients.
But how in the world do we figure out what that set of outputs is? Sometimes it's really tricky to see just by looking at the function. Luckily, there's this really clever algebraic trick we can use. We can basically reverse engineer the machine. Here's how this little hack works. First, you just replace the f of x with a y. Easy enough. Second, you use your algebra skills to shuffle things around and solve the equation for x instead of y. And then for the final, clever step, you just look at this new rearranged equation and see if there are any restrictions on y. Whatever those restrictions are, well, that's the range of the original function. It's pretty neat.
Okay, let's actually try this out with the function you see here. We start by setting it equal to y. Then, to get rid of that fraction, we'll multiply both sides by 4 minus x. After that, it's just a matter of rearranging. We want to get all the terms with x on one side and everything else on the other. And when we finally solve for x, we get our reverse-engineered equation, x equals 4y plus 2 divided by 1 plus y.
Now, take a close look at this new equation we've made. Remember our number one rule from before, the whole you can't divide by zero thing? Well, that exact same logic applies right here. But this time, we're looking at y. So what's the one value that y cannot be?
That's it. If y was -1, that denominator would become 0, and the whole thing would break. So, what does that tell us? It means our original function can spit out any number in the universe, except for -1. So, there's our range. It's all real numbers except -1.
All right, algebra is awesome, but you know what they say? Sometimes a picture is worth 1,000 equations. So let's see how we can actually visualize some of these ideas.
This brings us to something called the vertical line test. It's a really simple, almost foolproof visual check. Remember the most important rule of our function machine? For every one input, you can only get one output. Well, the vertical line test is how we check for that on a graph. If you can imagine drawing a vertical line anywhere on the graph and it hits the curve more than once, then it fails the test. It's not a function.
And this is a perfect example of what I'm talking about. Take a look at the parabola on the left. See how no matter where you draw a vertical line, it's only ever going to hit the curve one time? That means it passes the test. It is a function. But now look at the circle on the right. A vertical line can easily hit it in two spots at once. That would mean one x input is giving you two different y outputs, and that breaks our main rule. So a circle, believe it or not, is not a function.
So let's wrap this all up with the key takeaways. First, a function is just a rule that links every input to exactly one output. Simple. Second, the domain is the set of all the allowed inputs, the x values. Third, the range is the set of all the possible outputs, the y values. And finally, the vertical line test is our super quick way to check if a graph is a function just by looking at it.
You know, when you really think about it, domain and range are more than just a bunch of rules you have to memorize for a test. They're actually the boundaries that give every single function its own unique shape, its own personality, and its own mathematical story. It really makes you wonder, what other hidden stories are out there, waiting to be found in the functions that describe the world